All right, let's have a look at a Doppler problem here. So we have two train cars, let's call them A and B here, and each of these cars have an identical train whistle on them that has some frequency given as capital F. Car A is stationary, B is moving to the right. There's a listener that's between the two train cars and also moving to the right. Like we're going to let the listener's speed be S. I'll label that. The train car B has a speed 2s, and speed of sound and air is given to us as c. So yeah, this is just like some, Doppler exercises, basically. What frequency does the listener hear from car A? Let's just start there. So for car A, I'll call that frequency A. That's going to be the frequency that's emitted by the car, right? And then when we apply Doppler, we have to ask ourselves, okay, is the observer in motion? Yes, the observer's in motion, and the observer's moving away from the car, and that's going to have the effect to decrease the observed frequency. The source is not in motion, so the denominator isn't changed at all there. But that is our equation for the observer traveling away from a stationary source. So again, the perceived frequency, the frequency that the observer will experience, is of course going to be lower than the emitted frequency. So we expect that and we choose our signs accordingly. Part B, what frequency does the listener hear from car B? Let's look at this. This is cool because they're both in motion. So car B is also emitting this frequency F, and then applying Doppler, we see that we have the observer. Now the observer is traveling toward car B. Now you might say, yeah, but the observer is traveling more slowly. The observer is never going to catch up with car B. It doesn't matter. It doesn't matter. You just look at the direction. Is the observer moving toward or away from? It doesn't matter if the observer is ever going to catch the source. Doesn't matter. So since the observer is moving toward the car, the effect of that observer's motion is going to be to increase the perceived frequency. So I choose a positive sign here. So don't get all caught up in the overall picture when you're choosing your signs. Look at one aspect at a time. So when you're filling out the numerator, what is the observer doing? Is it moving toward or away the source or away from the source? That's all you ask yourself. In the denominator, now you ask yourself, what is the source doing? Is it moving toward or away from the observer? In this case, the source is moving away. So the source moving away is going to have the effect to decrease the perceived frequency. Since I'm working in the denominator right now, I'm going to use a positive sign because an increase in the denominator decreases the overall quantity, right? So as you choose your signs, be sure that you're staying in touch with what's happening physically. That's always your best bet. And then the final question here asks us about beat frequency. That beat frequency is, of course, just the difference between the frequencies. So I'll call the beat frequency F prime in this particular case. It's just going to be the absolute value of the difference between those two frequencies. So we can write that out as F C plus S over C plus 2S minus C minus S over C. Absolute value of that is a beat frequency.